Welcome to the presentation on the math class. The Java.Lang math class contains methods for performing basic numeric operations such as elementary exponential, logarithm, square root, and trigonometric functions. The math class was created to help programmers solve problems that require mathematical operations and is part of the Java.Lang package, so you don't need to import it. Most of these methods can be found on a calculator that you would use in a math class. Compared to other classes in the AP subset, the math class is special in that it contains only static methods. This means that you don't need to create an object from the class in order to use the methods in the class. All you have to do is use the class name, which is math, followed by the dot operator and then the name of the method. Let's take a look at some of the methods that are in the math class, and we'll start with the absolute value. The math.abs method returns the absolute value of an int value. If the argument is not negative, the argument is returned. If the argument is negative, the negation of the argument is returned. We've got a couple of examples here on the screen. So math.abs minus 8 would return 8. And then math.abs minus 8.4 would return 8.4. Square root. Square root demonstrates how to use the square root method. The square root method will compute the square root of any number that is greater than or equal to 0. The result is always a double and must be a positive number. An example would be math.square root 49, which would return 7.0. Base raised to a power. The math.pow method takes in two parameters and returns the value of the first argument raised to the power of the second argument. An example would be math.pow 5.3. The result is 125.0. 5 raised to the third power. Random number generator. The random number generator from the math class returns a double value in the range of 0.0 inclusive to 1.0 exclusive, including 0.0 but not including 1.0. An example of using the math.random would be math.random. Again, it's going to return a double in the interval of 0.0 to 1.0 exclusive. To generate a random integer, the math.random method returns a double that is randomly chosen from the interval of 0.0 to 1.0 exclusive. By casting the result of math.random statement to an int, you can generate a random integer. And a couple of examples here on the screen is math.random times 13. Possible answers would be 0 to 12, and we cast that to an int. If we took math.random times 17 plus 4, that would return possible numbers between 4 and 20. What the plus 4 does is it shifts it off of the 0, so it bypasses 0, 1, 2, and 3, and it would start your random number choices at 4 and then give you the next 17. In addition to the random methods in the math class, there is a random class in the util package. You will often need random numbers when you're writing software. Games use random numbers to represent the roll of a die or the shuffle of a deck of cards. A flight simulator may use random numbers to decide how often a simulated flight has engine trouble. A program designed to help high school students prepare for SAT may use random numbers to choose the next question to ask. The random class is part of the util package and must be imported to be used. The random class uses a pseudo-random number generator. A random number generator picks a number at random out of a range of values. A program that does this is called a pseudo-random because a program can't really pick numbers randomly. A pseudo-random number generator might be a series of complicated calculations starting with an initial seed value and produce a number. Though they are technically not random, the numbers produced by a pseudo-random number generator usually appear to be random, at least random enough in most situations. So a couple of examples here on the screen. First of all, we do have to import it from the java.util package. And random is an object, so then we have to create our own instance of random. So random generator assignment new random, we're making our own copy of the random object and we're calling it generator. And then to use it, we would do generator.nextInt if we wanted an integer, and we would have to give it a parameter. So the 10 that you see here on the screen is going to generate a number from between 0 and 9, and we're going to assign it to num1. Generator.nextInt 10 plus 1 generates a number from 1 to 10. The plus 1 gets us off the 0. It shifts the range of numbers so that instead of starting with 0, we're starting with 1, and assigns it to num2. Pi is not a method, but rather a public field. It can be accessed through the built-in value of pi from the math class, and pi will always have the value of 3.14159. On the screen, you have a demonstration of how to access the built-in value of pi from the math class. So math.pi assigned to the variable result. Pi is not a method, it is a public field. That concludes the presentation on the math class. Hope you have a great day.